Welcome to the Energy Capital Podcast. I'm your host, Doug Lewin. My guest this week was Daniel Barcelo, the CEO and chairman of the board of T1 Energy. We talked about how they got their name in this episode. I think you'll enjoy that. This is a fascinating company headquartered in Texas. They are building out a full end-to-end manufacturing of solar in Texas. They started with the acquisition of a manufacturing plant, 5 gigawatts of solar module assembly in Wilmer, Texas, just south of Dallas. They are currently building in Rockdale, Texas, about 60 miles north of Austin, a cell manufacturing facility. So obviously cells are much more complicated to manufacture, much more complex than the module manufacturing. They are also in partnership with Owens Corning to get the raw materials actually sourced here in America, so that when they are done with that process in a year or two, they will have end-to-end American solar manufacturing. So we talked a lot about the potential for American manufacturing of solar, how big it is now, what its potential is to maybe counterbalance China, which is really dominating electricity supply chains throughout a whole number of different components, including all parts of the solar supply chain. They're dominating that globally. Can America be a counterbalance? One of the things I really enjoyed about this conversation is Daniel has a great perspective, having worked in oil and gas for much of his career, really at the broad spectrum of energy. So I think that really comes through in the interview. I think you're going to enjoy that. This is a paid episode. If you're not already a paid subscriber, please become one today. You'll get access to all sorts of things, grid roundups, reading and podcast picks, other paid episodes of the Energy Capital Podcast. Most importantly, you will be supporting the work of this podcast, the Texas Energy and Power newsletter. They are not cheap to produce, and your $6 a month or $5 a month if you do an annual subscription is incredibly important, and we deeply appreciate it. With that, let's jump into the episode with Daniel Barcelo of T1. Dan Barcelo, welcome to the Energy Capital Podcast. I am very excited to talk to you. T1 is making a whole lot of waves. People in Texas talking about the company a lot. Why don't we just start from the beginning? What is T1? And tell us about the Texas operations you guys are standing up.
Great. First of all, Doug, thank you very much for having us. We're always excited to talk about the T1 story, something we're really passionate about as energy operators, managers, investors. Historically, T1 Energy is building a domestic solar and battery supply chain that we want to invigorate America with clean, scalable, reliable, and low-cost energy. This is all about advanced manufacturing. This is about how do we bring advanced manufacturing capacity to unlock the most scalable resources we have. That's what we're doing. We're doing this with our core foundational assets. We own and operate our 5 gigawatt solar module plant just south of Dallas. That's called G1 Dallas. And we are also building our 5 gigawatt solar cell plant north of Austin called G2 Austin. Those two assets are foundational. The other part of the investments we've made is we also own a supply chain of polysilica from Hemlock. Coupling that polysilica supply chain, coupled with the cell plant, coupled with the module side, we have a tremendous capacity to unlock what we think is a very scalable, renewable power asset we have available right now.
Yeah, it's pretty exciting because I see the vision of what you're trying to do here, right? Because what we have in the United States right now, if I'm not mistaken, and you correct me on any of this, I get wrong, this is your world. But my understanding is we've got something like 50 to 60 gigawatts of capacity of solar module manufacturing. So that's sort of like the last phase where you're bringing like the assembly, kind of bringing it all together. But you guys are going way upstream to raw materials. And you mentioned something just there. I'm not sure I heard what you said, but I do want to get more into this. I think you guys announced a deal with Corning, right, for some of the raw materials. Not sure if that goes through to the wafers, but I do kind of want to break that down a little bit, Dan, because I think the audience will really appreciate it. It's very important. I think it's very important that the United States have the full end-to-end capability for manufacturing. And it looks to me like you guys are doing that with the partnership of Corning upstream, then actually making the cells correct in Rockdale, which is what you're calling the G2 Austin plant, but close enough, like 50 miles or so from Austin. I believe at the near the old Alcoa site. You could talk some about that. And then putting it together in Wilmer, south of Dallas. So you're really kind of doing that like soup to nuts, end to end, full supply chain, no?
Yeah. Look, when we acquired these assets at the end of last year, what we acquired was, at that point in time, the world's most modern solar module manufacturing facility. And that's operational, that's up and running.
That's Dallas, right? That's G1 in
That's
Dallas. Yeah,
Dallas.
okay.
That says 5 gigawatts solar module manufacturing, G1 Dallas. It is one of the world's most modern facilities, up and running, ready for business. Highly automated, yet also employs a good number of people, over 1,000 people workforce, and a very large payroll as well in the South Dallas community.
And Dan, that 1,000 jobs is current or that's projected?
That is current.
Currently 1,000 Texans employed in South Dallas.
That's correct.
Yeah.
That's correct.
Mhm.
We're currently over 1,200. And with the acquisition, we also acquired a polysilicon supply agreement to supply gigawatts of polysilicon to be the initial part of the chain. Now, we did announce earlier that we have the arrangement and the contracts with Hemlock to convert that polysilicon contract in part to wafers. So in order to complete the chain, you're basically taking the polysilicon, which is ingots and then wafers. Then you're taking the cells, and then you're taking the modules to the end, or the module, the solar panel. So when you think about the solar chain, you're going from the polysilicon, ingots and wafers, cells, and modules. What this acquisition did was we purchased the module plant, which just gets us to the end customer use. You mentioned the market size of 50 to 60 gigawatts. This plant is about 10% of the U.S. On the polysilicon side, we wanted to secure American polysilicon in order to supply an American module plant. Until we have our solar cell plant up and running, we currently are sending our polysilicon to Southeast Asia in order to make wafers and cells, and then bring those cells back to the United States. By the fourth quarter of 2026, we anticipate to have our G2 Austin site up and running. And at that point, what we'll be doing is taking wafers from Corning, bringing those wafers to G2 Austin, and then making the cells, and then taking those cells to G1 Dallas to make the modules.
Amazing. And my understanding, and this may be a couple months old, but I don't think it's terribly out of date. There's really only like a gigawatt or maybe two of solar cell manufacturing in the United States. So when you say you're 10% of the module assembly in the Dallas plant, that Austin plant, when it comes online, will represent, maybe by that time there'll be others, and maybe I'm missing some or I'm just getting it wrong, but that's a huge percent of the entire capacity of the United States, right?
The cell capacity is higher. It's above 10 gigawatts.
Okay.
There are differences in that capacity.
Okay.
There's capacity from different technologies which are non-silicon based. There's also technologies of cells that are older, PERC style. This will be TOPCon technology based and is one of the most modern and most energy efficient technologies.
So that's First Solar is like the other 10 gigawatts, basically, right?
That's correct. For solar, and then there's others on the PERC side and that technology.
Yeah. Okay. Got it.
But on the silicon-based TOPCon, this will be one of the first.
Okay.
So with that TOPCon technology, that provides better efficiency. It provides better in terms of what customers want, in terms of energy density, in terms of deployment. So that's our focus.
Okay. Incredible. And I will put some links in the show notes, stuff like this. The capacity of China is orders of magnitude more. Like I said before, I think this is really important that this start to happen in the United States. Going to take a while for this to all scale up, but this is obviously a huge step in the right direction. What is the reception in Texas? I've seen you post on social media, various visits to the plants by various elected officials. Obviously there's a notion out there that at least, and it's true that some in Texas political leadership are hostile to renewables. But I think by and large, there's an awareness out there that oil and gas and renewables actually can have kind of a symbiotic relationship. Curious, but you've written about that on LinkedIn, so I would love for you to talk about that.
Sure.
So there's really two questions there. Sorry I do this. I ask these multi-part questions. But really, what is the reception for political leadership been, and what do you see as sort of the future of Texas energy with sort of the coexistence of oil and gas versus renewables? Where do they compete? Where are they symbiotic?
Sure. Well, first of all, the reception has been phenomenal. Whenever anyone's bringing in a large payroll, a large labor force, and also bringing in newer advanced manufacturing jobs, that is something I think everyone across the political aisles can agree on and see as a good thing for the United States. Bringing supply chains back to the United States are also very important. And I think all of that is resonating. There's the obvious tensions and competitive tensions we all see and read about with China versus the USA. So having more of the energy manufacturing and having more of the energy security based in the US, that's all positive. So it's resonating from the Washington to the state to the local levels. So that has been very, very, very clear and very consistent. Now, I kind of grew up in the oil and gas sector. Since the early 90s, I've been working in oil and gas, and I am an old oil and gas guy who's done capital markets on that and run oil and gas companies globally. At the end of the day, it's really about providing the lowest cost energy in whatever form it is and delivering that energy at a cost competitive basis to the customer. That drives the philosophy at T1. I almost shrug or shudder when I hear the word renewable sometimes. I think it's done a disservice to the solar industry. It's done a disservice to the wind industry. This is just conversion of materials to electrons to enable power, to enable electricity. And I think that solar and solar plus storage can be an incredible competitive advantage versus other sources of fuels. I spent years drilling natural gas wells in order to get gas to create power, the power, from the generators, right? This is very similar to me. Now we're spending years in capital to create machines that from the silicon sources of polysilicon create the machines and the panels to make electricity. So it's either drilling or finding the gas to feed the turbines to make the power, or it's putting up the machines and finding the silicon, the polysilicon to make the electrons. So in my mind, this is all about delivery of energy to the market, and the market needs it. The demand growth right now that we're seeing in the US is unprecedented. It is driven by small amounts of residential growth, but it's driven by industrialization, and it's obviously driven by the rise of AI and data center loads. The only source of power that can match the ramp that AI wants is solar and batteries, at least for the next 4 years. If we're going to be very competitive over the next 4 years, as hopefully people a lot smarter than me try to go for the AGI and try to get to, that level of where we can be as a society, the gigawatts, per week, gigawatts per month is what everyone's talking about. The plant we have at G1 can produce 5 gigawatts a year. If I had the demand signals, I could create another plant like this within a matter of another year. We are able to deliver gigawatts and gigawatts of solar. Some will say, well, it's interruptible power. Well, when you look at where demand is kind of interruptible too. As we know in Texas, from 3 o'clock to 7 o'clock, it's a very different load profile than 3 o'clock to 7 o'clock at night. So the matching of demand is something I think that does a disservice. And once you put batteries and grid level batteries on, we see it in ERCOT all the time. We see it in CAISO in California all the time. The grid is more robust when batteries and solar are part of the grid, full stop. So we think that batteries, and to be clear, we used to do batteries. We have paused on the batteries now. We aim and strive and have ambitions to batteries in the future. Right now, it's all about the solar, and it's all about supplying that supply chain. The last part of this is all of that's great, but I believe that we can build this in the United States. And I don't believe this is anything, we'll say, less competitive or that we don't have versus other places. Let me just expand on that in a moment. When we look at the automation of the machines we're buying and the ability for these machines to run, fundamentally, we're turning silicon to polysilicon to a wafer to a cell to a module. This is just the transformation of materials into something that collects photons to create electricity. The largest conversion costs of all of that has to do with water, has to do with electricity. There's some specialty gases. There's, in the case of the modules, there's frames and there's glass. But fundamentally, these are all very commoditized products. Texas is very lucky to have extremely competitive electricity prices, extremely competitive water prices, extremely competitive specialty gas prices, and extremely competitive natural gas prices. So what this is getting distilled down to is a labor cost differential. Given the high automation, both at the module plants, the cell plants, the wafer plants, that labor component is less and less and less. So I believe that we're actually seeing a competitive advantage now where these machines can be here. There's still a higher labor cost structure than in other parts of the world. That goes to the wages America pays its employees and the good wages and the living wages. It probably also ties into a bit on how wastewater is treated, which I think is probably much more important when we talk about what the impact the solar industry or data center or other people can have, is the immediate impact right now on wastewater. So those two parts are probably the highest differential in cost relative to the rest of the world. When I build, for example, in G2 and Rockdale, those machines that come in and that are building there, those machines don't know if they're in Egypt or Turkey or Nigeria. They have no concept of where they are. Those machines just know they need power, water, and they need wafers. So that's where we get to how we can be more competitive.
You mentioned load growth from AI. In preparing for this, it caught my eye. I had missed it at the time, but I'm going to follow your LinkedIn more closely now. You had a post a couple months ago that I thought was really extraordinary. That was specifically about oil and gas. So, yes, we have a lot of load growth from AI that is already hitting the system and more to come. The far west zone in Texas has tripled its energy consumption over the last 8 years, a tripling in 8 years. And some of that is Bitcoin, cryptocurrency. There's probably some initial AI, but there's a whole lot of oil and gas load as well that is connecting to the grid. And a few years ago, 6 of the biggest oil companies operating in Texas went in together on a study from S&P Platts and showed their kind of demand growth curves that there's already, I think, the 4 gigs or so of grid tied oil and gas sort of fracking operations, but also compressors and all the rest, and that could go as high as 10 to 12. And this was just in the Permian, and I believe just in the Texas part.
Mhm.
You were writing about this. And again, you referenced that you and other executives at T1 have spent much of your careers working in oil and gas. And you put in there that last year, more than 88% of the electricity produced there, meaning I believe you meant in Permian, you may have meant Far West Zone, was from solar and wind farms, according to an analysis of the actual electricity production last year.
Mhm.
That is extraordinary. I've never seen that number before, but it kind of makes sense when I sometimes will post on social media or in my articles, like the overlay of where the Permian is geographically, obviously in far west Texas, sort of where the right angle of Texas and New Mexico meets, kind of just to the east of that and to the south of that. And then if you look at that right next to maps of where the sunniest parts of America and the windiest parts of America are, it's all right there. Can you talk a little bit more about what you're seeing in the oil and gas? Like,
Mhm.
are you having conversations with people in that industry that are like, we're trying to purchase more renewables? Can you get some of your solar panels out here? Are you hearing that kind of chatter from folks in that are
Yeah.
still in that world?
Look, part of it is geography.
Yep.
Southern and western Texas, all the way to California, is blessed with a lot of great solar in terms of radiation levels. And in terms of wind, you have straight down the center and through West Texas, you have wind. So you have a lot of overlapping wind and solar power and makes West Texas extremely, extremely valuable in terms of that resource. So again, I almost would drop the word renewable. This is as simple as, according to, I think we use Rystad in that study, there's about $1 per barrel in terms of BOE equivalent of savings that companies could make by removing their power from the grid and using electricity rather than running gas turbines or diesel generation, which is expensive. So the idea is, how do you produce and sell more of the product you're making rather than use it to run your turbines with gas or diesel? So by using power from the grid there was a savings of about $1 per barrel. When you look there, I think the numbers there were growing to around 8 gigawatts today. And according to Rystad, there was an increase of a further 3 gigawatts on the Texas grid just from the Permian. So it's just making an example that in order to produce even the oil and gas, in order to lower operating and lifting costs, the switch is to go to grid power, which is primarily renewables, which is primarily wind and solar. And again, this goes to just the cost nature of it. So even oil and gas, which in that area are a third to half of production of the U.S., it's phenomenal levels of production. Those resources can be produced. Those resources can be used for better energy and chemicals and plastics in the United States, or they can be exported, so to speak, to export American exceptionalism in that form in terms of energy exports. So I think there's a lot of combined ability for it. The benefit the ERCOT grid gets from solar and even from wind is it's driving energy costs lower. And you mentioned this before, that maybe there's some biases in terms of left and right, in terms of wind and solar versus oil and gas. But if you look at Texas, it's just making an example of what can be built now, what's economic, how do we build it fast? So I think those are the key drivers. So we flag that as, it's a great example of how it's just energy, and the cheapest forms of energy and the most efficient forms of energy are there supporting the largest forms of exports of American oil.
Yeah, I actually love that framing or reframing that we often get so much into the label that goes in front of the word energy, the adjective, the modifier, instead of focusing on the energy itself. And this is what is great about Texas is you do have this system of economic dispatch, and it's going to be the lowest cost energy. And that typically happens to be wind and solar, but it's not because it's wind and solar. It's not because it's renewable. It's not because of some attribute other than it's cheaper. Like that is really what kind of is driving its adoption.
Thank you for listening to this free preview of the Energy Capital podcast. You can access the entire episode as well as the Texas Energy and Power newsletter archives at douglewin.com. That's DOUGLEWIN.com. You'll also be able to attend paid subscriber-only chats, and you'll receive full access to all of the Texas Grid roundups and reading and podcast picks. Please check it out, and thank you for listening.